Okay, my friends, this is going to be fun. I just got this from a friend. The vanishing neutrinos could upend fundamental physics. They're talking about the Majorana particles could solve a big antimatter mystery and ramping up around the world. Well, they have been ramping up because of our research. I can show you these particles. That's the Majorana particle right there. They're twisted particles of light. And they say there's one that goes this way and one that goes the opposite way. I don't agree with that, and I'll show you why. Okay, this is from the light experiments we did showing that the light literally spins. Now, I see this as a right-hand spin, although I can't say for certain that I'm right because I see them coming this way and I see them coming that way. They could be right about this back and forth, but I see them as a normal right-hand spin. In other words, I can't account for exactly what we're seeing here other than the fact that light is a spinning particle, and that I can show you for a fact. And it comes through this way, and they bang into each other, yes. And when they bang into each other, they form more of a glow. So like these are two particle streams interacting, getting a more of a glow. When they're all by themselves, they have much less intensity. When they're in little bundles, they try to push away from each other. That's what creates the interference patterns. It's not an overlapping pattern like this, it's a push. That's why they push each other away, and you end up with these black stripes in between. Alright, LHC, Large Hadron Collider, is gearing up to do what we are doing. They say they want to break physics. We already broke it. Okay, my wonderful friends, this is going to be extremely exciting and very, very important for the world. They're talking about Majorana particles, Majorana, however you want to pronounce it. Theoretical. Now, this theoretical means it's not real. They just think. Physicists have predicted in certain materials, collective behavior of electrons, which I'm going to be showing you in a second, can display the property of Majorana fermions, which means excited electrons. Hypothetically, elementary particles, that means the smallest, elementary means the tiniest, particles that could simultaneously be matter and antimatter, in other words, at the same time. Well, let me show you what they're talking about, because we have them, and I can show you them. Don't forget, this is the key word, collective behavior of electrons. So they're seeing an electron as a collective particle and displaying this both pieces, an antiparticle and a particle at the same time. Let's see if I can show you that. Okay, my friends, this is two Majorana electrons at the same time. They're positive and anti-positive at the same time. They're negative, anti-negative, whatever you want to call it. There's a black and a white ball. One of them explosive, one of them is exact opposite of explosive. It's contractive, it's a sucker. It sucks the white one to it. So this is, in my mind, exactly what they're talking about. They exist at the same time, attached to each other. One of them is exactly the opposite of the other. And two of them back to back create a photon, which is not like an electron. It is a bouncer. It bounces off things, and you see it as light. An electron fuses into you as static or lightning or electricity. But each side is a Majorana electron. So don't forget, as I said, that's the Majorana electrons. Back to back, they create a photon. So how did we get there? This is light, and that photon is way back here, but its magnetic field, because it's a magnetic particle, you could see it had a plus and a minus to it, creates a big wave in front, so it's particle-wave duality. They move together normally. However, we put it through a Venturi right here, which is a constriction device that forces these big fields, these big balls of magnetic influence to crush at that Venturi. And when they crush, and I can't tell you exactly why, they disassociate the black particle from the white. The white becomes a shower, the black particle just stays a black particle. And I will show you that as well. But we also get, after the spray of white showers, the spray comes out here, all of a sudden it hits right out here, it creates the Higgs fields. Because at that point, it has slowed down enough where it reattaches to other electrons in the cloud and becomes a spinning particle of field. Now, we did catch a really strange one here, this one right here. That one there, I don't know what to say about, but I believe this was a reverse spinner, and they normally have a right-hand spin, and I can show you where that particle originated. Now, we have also seen where we could create blue light from red light. So we've compacted that particle by forcing it on both sides to pinch and then squirt out like a toothpaste tube, a more intense color. So that's something we need to look at. Blue is a different issue. That one there is just so energetic that we don't pick it up as like you see here, back-to-back particles. We see it as a, well, that's what we see. So it looks like there's something going on back-to-back. When it's expanded, you can see it a little better. As it concusses and slows down, you don't see anything other than little white dots. But that's just a more energetic spinning particle. In other words, that's the particle. It spins through the air. Now, as it spins, it's way back here, but the field is way out here. So it keeps spinning, and you see the field. Now, here, it takes right off, and zip, the particle literally leaves the wave and goes through that venturi and creates the electron part, and then the muon, the dark matter part, just goes around. But that's how they spin. They don't flap like a wave. And this is a single venturi, so it's not a double slit where they're going one way and this way, and that's why you have this interference patterns. The interference patterns are push to shove. In other words, as those white particles are coming through, not a single one of them wants to be near either any other one. The white ones want nothing to do with each other. So as they come out and then they start to reconcuss with particles that are in the air and to create these Higgs fields, they, at this exact point in time, start to reassociate and slow down and create all that interference. But between here and there, we have raw energy. So my point is, we saw the Majorana particles were back here. They were black and white together. And that's what they say. Both particles at the same time, an antiparticle and a particle, is what they call it. I call it just an electron with its dark matter attached to it. But here we've separated them. That's one step beyond the Majorana, or whatever kind of orna we want to call it, electrons. All right, the takeaway here is that these interference patterns are not flappy waves to do that. Every white one wants to keep that one away, and that one wants to keep this one away. So they set up these stripes. Now you have guys pushing from behind, pushing the guy in front, and pushing this guy away, and that guy pushing this way, and that gives you these stripes. Now, in the center, you have all kinds of, because it's a circle. Don't forget now, this is spinning. So some come through, they go that way. Some come through, they go that way. But they're all over the place. You see them? They're all over here. There's not just one. So they're fitting all of these fields and crushing in together, and then when they split out the other side, they sort of split off. So some will spray that way and some will spray that way, just naturally. However, they still want to be away from each other, and when they are in this extremely energetic condition, they just push every way. Get away from me! You get away from me! You get away from me! You get away from me! And that's what you end up with is more brightness in the center because there's more central interaction. But then all of these do the same thing. They say, get away, you get away, you get away, you get away. And that's how you end up with that interference pattern. We have to tap right here before it starts to recreate the Higgs. You see the Higgs fields getting recreated? Here they are right here. That's right after the muons, bosons, fermions, holes, whatever you want to call them. I call them raw electrons. At the end of the raw electron cycle, you start to reattach to the black balls. And then they, at that point, become Higgs fields, is what I can see. And they're slowing down. It's a concussive phase, and then they just sort of blend in with the background. All right, you've seen the particle accelerated. This is what it sits and looks like without being accelerated. It has these rings of electrons that coat and try to get into the dark matter. So then the electrons try to get into the dark matter. Their dark matter hangs out this way. More electrons come in and they try to get into that dark matter, so their electrons push out that way. And they just keep stacking up these circles around it until it no longer has any attractiveness. And that's exactly what they say for stationary particles, which are nothing more than light particles, only they're just stationary. Now, sound is exactly like light. It's identical. It's the same particle, only it's not quite going fast enough to be considered light. Once it hits a certain speed, it becomes an energetic particle, no longer a vibrational particle that makes sounds that you can hear. It's beyond that frequency, and it's ahead of sound. So now it becomes light, basically. All right, we're going to get into electron flood theory right now. And I want to explain to you that atoms like this, these are atoms, and they get stable at certain quantities of particles. Now, every electron like this is all that exists. And there's just more and more and more of them in a bigger snowball. And that is what's 1839 of these particles in a little ball become stable. At that 1839, they're pretty stable. They want one more electron to become a neutron, which is 1840. However, inside the core of this, all the dark particles will go to the center. You see, you got the black and you got the light ones, the white ones normally. Now, the dark ones don't mind being next to each other, so they congregate in the center. The white ones say, everybody get away from me. So they have to be attached to the dark ones in matter until they go through the Venturi. That's the only time I've ever seen them come apart. And CERN and all of them say it's an extremely rare event. We make it happen very simply, but that is the only time I can see it happen, to see them come apart. Now, we've seen the electrons. We've seen two of them back to back. They come with photon. So we call that the Majorana particle, or whatever you want to call it. Now, in the core, they create a core like this. But inside the deep part of this is the dark matter. And all that wants to do is pull white matter in. And the white wants to be away from the dark, from the white. It likes to be next to the black. They seem to be very happy being attached to each other. But the white does not want to be next to another white one. But the dark is so attractive that it can hold these whites right next to each other in a little box like that, create a photon. We saw it, there's no question it happened, and we saw them separate, no question it happened. Now, what is everything made of? I say it's made of electrons in masses that start with hydrogen, which is right down here, and instead of being one gigantic proton, like they say one huge ball, it's 1,854 electrons. Now there's 1,800 and let's say 50 or something like that, 1,800 and whatever, in the core, and then there's one or a couple floating around the outside of it that want to get into the core because the dark is so attractive that it'll have all of its whites around it, but they'll still want some more white ones will get into it. And they say, no, you have to stay away. That's what's called the quantum distance. And the white particle will always face inwards. After the first round, the white particles always face outwards at the core. And then as you get into your valence shells, your shells that surround it, the white ones will always face inward. But they'll be pushed away by this white one. So there'll be this white one here wants to get in. This white one's still pushing it out. It says, no, you can't get in here. We have plenty here. So you'll end up having white surrounding the dark. Then you'll have white surrounding the white, pushing their way in. And their darks will be facing out. And then you'll have more whites that will want to come in, and they will literally attach to those whites, and it'll get to those blacks, and it'll get to a point where you'll reach stability. And then it won't take any more, if there's exactly the right number of electrons, and it's not an isotope, it will be one of these stable particles. Now, isotopes just mean they have one more or one less or two more or two less or several more or several less extra electrons. So they're not really stable. They're in a state of semi-decay, or they call them ions, or, they're nuclear decay particles. Sometimes if they're just gigantic ones like this, that's from gigantic fission of huge, massive particles that have millions, well, hundreds of thousands. I think it's 358,000 is uranium or plutonium, I can't remember one of them. 358,000 electrons, not just 92 or whatever they call it. 238, uranium-238, I think it is. Anyway, it's altogether different than they're saying, and the Bohr model never worked. And you can't have the complexity that we have with these little bits and pieces. It's like having a half a dozen nuts and bolts and you build airplanes and freaking nuclear bombs and everything else. It just never did work. So this is the new model, electron flood theory. And I got a couple of little doodles to show you to make sure you understand where I was coming from, what I was talking about. Red laser, remember the pulses we saw, they were just waves at first, but we know there was a particle involved creating the wave. Then it accelerated, then it exploded, then we got 200 times increase power here. The black balls rolled around the outside, they reattached, Higgs fields, have a nice day. Now, what is everything made of? That. That's everything there is. Muon, dark matter, boson, whatever you want to call it. And the two of them together, we'll call them the Majorana. That's fine. I don't care what you call them, but I see a raw electron, and then I see the dark matter, muon, boson, whatever it is. When it concusses, that's when you get the electron showers, and the muon says, hey, I'm fine. All I want to do is find that guy again, or find somebody else to attach to. So we know they can separate. We saw it. There is zero question about that. I never thought it was possible. Nobody would ever have been able to convince me of that had I not seen it with my own two eyes. Now, so, bottom line is no more Bohr. Bohr is a no more. The new model is electron flood theory. It solves 100% of material interactions. If you can come to me with any material interaction, I will be able to explain it with electron flood theory, which states that there is nothing but electrons, and they can also create photons, and then they create bigger and bigger pieces of particles, which are just like decay particles, they call them. There's zones of stability, and these are the zones of stability, and they happen because of some form of a frequency resonance, and they just lock in at certain. Everybody pushes and shoves and says, "I'm okay, you okay, I'm okay, are you okay, I'm okay." Whoop, stop, and it locks in at that frequency and that number and that molecule, or so forth. Now, if you heat it up and you cause extreme amounts of energetic influence inside of it, you could change its molecular structure. We know that. And it could change its atomic nuclear structure. We also know that. And the way is because now you're forcing these to decay and degrade or fuse or whatever you're doing with them. The nucleus normally is pretty stable when it hits its correct quantity of electrons, which is protons of 1839 and what they call neutrons of 1840. And they just form bigger and bigger snowballs, but they just know that there's that many particles. They're not really in those, like one big ball of positive protons and one big ball of neutral neutrons. No, they're all one big mass like this of electrons. And it just happens to be that the numbers work out to be these masses. The mass is the weight, atomic mass units. How much does it weigh? And they base it off, I believe, a proton. And it's electron is about 1839 or 1840 times smaller than a proton. So I say that in a hydrogen, where there's supposed to be one proton, there's 1839 electrons. And then as you go up where there's supposed to be 50 or 60 or 100 protons, you've got 1839 times that number of protons makes the number of electrons And then, again, it's a snowball of dark particles as much in the center as it will accept, and then they start to form around it. So they still want to get into that dark matter. And that's why they get sucked up in these zones, just not solidly inside, but around it in distances. The ones that are in the core seem to be really locked up tight. And as they get out, they sort of separate in these angstrom unit distances, which we call orbitals. I hope that made sense. I know I got a little long with these things, but that's the way it works. Now, just one final thing. I'm sorry, I'm just got to say it. You got atoms, and then you got molecules. Well, an atom is exactly like a molecule, only they're attached together. You might have one like this and another one that hangs halfway into this one, and they share each other, that type of thing. But the center of everything is always, 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 always going to be the darkest particles, which so you never see them. All you see is the glowy particles. But when you concuss them in a Venturi like we did, they separate. That's how we saw them. Nobody else has ever seen them.